Hi and welcome to Geeks for Geeks. Today we would be discussing the problem Techfest and the Q. So let's not read the problem statement, let's just have a summary of that. I would assume that you have already read the problem statement. So here in this problem you are asked that you are given A and B. For example, you can take like 9 and 12. And then what you need to do is you need to find the summation of power of prime factors. Okay? Power of prime factors. Now, for 9, the prime factor is 3 square. So the power is 2, so we would add 2. And from A to B, that is 10. For 10, the prime factor would be 2 multiplied by 5, which is 1 plus 1, which is again 2. Then we have 9, 10, 11. So 11 is a prime in itself, so it would be 1. And then we have 12, which is equals to 3 multiplied by 4, which is equals to 2 plus 1, that is 3. So we have 3 plus 1, 4, 4 plus 2, 6, 6 plus 2, 8. So we have 8 as an answer. Okay. So we need to start from A and we need to go till the value of B. We need to find the prime factorization, get hold of the powers of prime factors and have their summation. Okay. So now, after you understood the problem statement, you need to know the prerequisite of this problem. The optimal solution of this problem requires you the understanding of prime sieve of or sieve of Arrhenius. Okay, prime sieve. So now, please pause this video at this instance, get a hold of prime sieve or what is prime sieve, and then again come back to this video. So as you know that the optimal solution requires prime sieve. So the basic solution or the brute force solution would be that you find the prime factorization using loop and you start a loop from A to B, find the prime factorization of each number, get hold of the sum and you are done. But that won't be the solution. Okay. So now, let's talk about the optimal solution. For this, we would have here like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Initially, we would say that everyone is a prime factor, like just we do it in prime sieve. So we would say, okay, this, 13, 14 and 15. These are the indexes and these are the values. These are the indices, these are the values. To have a better understanding, I would just say this is the index and this is the value of the array itself. Okay. Now, as we do it in prime numbers, we would handle the 1 explicitly because 1 is neither a prime number nor a composite number. Then we would start from 2. And if the value of index is equal to the value that is there, then we would have the multiples as composite number. This is what we do. Like if we get hold of a prime number, we would mark all the multiples of that as composite number. This is what we do in prime sieve. And this is exactly not just one, like Siddharth, you are teaching prime sieve, but you told that prime sieve is a prerequisite. No, this is a observation in prime sieve. What is that observation? 2. So the value of index is equals to the value of the value. What does this indicate? If the prime sieve P of I is equals to I, this means that this is a prime number. This indicates this, what I am trying to move forward. So all the values, I won't just mark it as composite, but I would mark the number which is marking it first. Like multiple of 2 is 4, so I would say 4. You have been ticked out by 2. 6, you have been ticked out by 2. 8, you have been ticked out by 2. 10, you have been ticked out by 2. 12, you have been ticked out by 2. 14, you have been done by 2. Then we come across 3. Now the value of index is equals to the value that is present. This is a prime number, so all the multiples of the prime number would be a composite number. So we would go to 6, but 6 is already marked by someone else. Because how we know that it is already marked? Because P of I is not equal to I, that means it is already marked. This just tells me that already marked. Okay, so if it is already marked, we won't touch it. Then we go to 9. 9 is not marked. 3 multiplied by 2 is equals to 6, which is already marked, so we don't do anything. We go to 9. It is not marked, so we would just say 3. Then we would go to 12, already marked. We would go to 15, and then we would have 3. Then we go to 4. P of I is not equal to the value, so it is not a prime number, so there is no point in marking out the multiples of that. We would go to 5. Yes, 5. P of I is equals to I. So multiply of 10 is already marked. 15, it is already marked. Then we come across 6, not marked. 7. 7 multiplied by 2 is 14, already marked. We don't do anything. 8 multiplied by 2 is 16. It is out of the scope. So there is no point in moving forward. That would just keep moving forward. So now if you notice, by doing this approach, what we are getting, each value is having the smallest prime factor by using the prime sieve. See, the smallest prime factor of 8 is 3. The smallest prime factor of 8 is 2. The smallest prime factor of 10 is 2. The smallest prime factor of 12 is 2. Okay, Siddharth, you found out SPF, that is smallest prime factor. But how would that help? It would help me a lot. You know how? See, for instance, let's say I want to gain, let's just have this, yep. Now see how this array would give me the answer. See, if I want to find the prime factorization of 12, so we would have 12. The value at there is 12 is 2. So we would divide 12 by 2 and we would write here 2. After dividing by 2, it is 6. In 6, we have kept 2. So see, let's say we have 12. So we would go to 12. 12 has 2. So we would keep here 2. Then we would divide it by 2. Because 2 is there, whatever value is there, we would divide it. After dividing 12 by 2, it is 6. Then we would go to 6. What value is kept there? 2. So then we would again multiply it by 2. Then what is 6? 6 divided by 2 is now 3. What is kept at 3? 3 again. So multiplied by 3. And then 3 divided by 3 is equals to 1. When it goes to 1, we would stop at that instance. And if you observe, we have got the prime factorization by using this array of prime sieves. Let's do it for one more and then we would get a proper idea of that. Let's say we have something like 14. So in 14, we have here 2. So 14 divided by 2 is equals to 7. In 7, we have 7 only. 7 divided by 7 is equals to 1. We would write here 7. So the prime factorization of 14 is equals to 2 multiplied by 7. So we have this value. Okay. Now we have 10. So 10, it is kept here as 2. So we would divide it by 2. And we have 5. 5 kept here is 5. So it would become 1. 2 multiplied by 5. That is the prime factorization. So this is a small thing. So the idea is that the very first number which cuts out all other hash the value in prime sieve is its smallest prime factor. And we would use this property of prime sieve to get the SPF, and we would get the SPF of each of the values. We would divide it by the given number, and then again we would use the SPF of the resultant value. Again we would divide. We would keep doing that until we have 1, and corresponding to that we would have the prime factorization. Done? This is what we are done. So we would use this property. Okay, to get the prime factorization from A till the value of B. This is a very great technique of prime sieve to get the prime factorization. Now let's just try to code this. And it is like the implementation is very akin to that of prime sieve. So we would require a vector. So as long int is used a lot, so we would say using ll is equals to long int. Okay, so we would say vector of ll is equals to SPF array of b plus 1, because we would be using the index b also. Then we would be using for int ll I is equals to 0, I is less than equal to b, and I plus plus. And at each index we would fill the value that is there. So SPF of I is equals to I. Initially everyone is a prime number. Next we start with 1 because we handle 1 explicitly, just like we do in prime sieve. So for ll I is equals to 2, I is less than equal to b, and I plus plus. Now if we get hold of a prime number, that is when a number would be prime number, here if SPF of I is equals to I, so SPF of I equals to I, then it is a prime number. So we would mark all the multiples of the prime number as that. So for long I is equals to 2, I is less than equal to b, and I plus plus. Then we would say if SPF of j is equal, SPF of j is equals to j, then we say SPF of j is equals to I. What is this meaning? That if this is not there, if it is not marked, then only we would mark. If it is already marked, we would simply ignore that. It is done. After this instance, we would start doing the values. So we would say ll answer is equal to, initially answer is equals to 0, and then we would start a loop for long j is equals to a, j is less than equal to b, and j plus plus. At each instance long count is equals to 0, and we would say long, we just make a copy of j so that we don't disturb the j with value. And while the value of I is greater than 1, we would keep dividing it. We would say c plus equals to 1. Each time we divide, we would add the power, and we would divide I divided by SPF of what? I. SPF of I. Okay, and then we would say answer plus equals to c, and then we would return the value of answer. Now let us see if we can get an AC through this. Seems correct. And yes, we got an AC. So this was it for today. If you face any difficulty, or if you have any suggestion, or if you have any appreciation, of course, make sure you drop it in the comments so that I can either learn from it or I can smile by looking at it. That's it for today. This is me, Siddharth Hazra, signing off. Thank you.